Hello and welcome. Today we're going to be making a similar effect to the Meteor Strike ability from the Diablo series. We will be focusing on the fiery version of this ability, but at the end you can pretty easily adjust the whole effect to look like any other element. This tutorial is made out of separate parts. First, I'm going to show you how to create this ability with the Unity particle system. Then I'm going to show you how to create the shaders, textures in both Photoshop and Substance Designer, then meshes, UVs, and of course the URP materials themselves. So, let's begin. The first is phase 1, and we are starting with the glow. The glow has duration of 1 and lifetime of 1. Also, the start color is 100 on alpha. On emission, it's 1 as a burst. Inherit velocity is enabled. Color over lifetime is mostly in the middle for color and alpha. Rotation over lifetime is 80 on the y-axis and 0.7 at the last. Z and x-axis are both 0. For the renderer, we are using a mesh with a uniform random. We are using a funnel mesh and the skill shader glow underscore 03. The second part is the distortion. We are using a start color of 255. Emission as 1. Color over lifetime is mostly towards the end. Size over lifetime is 1 on X and Z axis. For the Y axis, it goes from 0 to 1. For the renderer, we're using a mesh with a funnel and a distortion shader. Next, we have the particles. We have the duration of 0.4 and the color hex code is E0B964. The emission is 150. The shape is cone shape. Velocity over lifetime on x-axis is 0. The same goes for z. And on the y-axis, it's 1 with a curve, which goes to 0. On the orbital x-axis, it's 0 on x and z. On y-axis, it's 5. It starts at value 1 and it ends on value 0.31. Limit velocity over lifetime has a speed of 4, which ends at 0. The same goes for drag, but the value is 5. Color over lifetime is mostly at the beginning. Size over lifetime is 1. The curvature bends at 0.17 and ends at 0. You can move this up. Rotation over lifetime is 155. Rotation by speed is 45 on angular velocity. On the noise, we are using strength, which is 1. It goes from 0 to 1. Texture sheet animation is 2, since we are using a material that has 2x2 tiling. And the renderer is stretch billboards with our ember material. Order in layer is 5. Then lastly for phase 1, we have the ground effect. At the moment it's positioned on 0.2 since it's not decal. The duration and lifetime is 1 with a delay of 0.1. The hex code is just zeros. Emission is 1. Color over lifetime is exactly in the middle. Size over lifetime starts at 0.34. And the second key is at 0.01 and ends at 1. The renderer is using a mesh with a quad and a circle material. Order in layer is 0. So this is the final result for phase 1. Let's continue on to phase 2. For this part, I would recommend using your own rock asset, but for now, let's continue with this. Position is minus 1.5 on x-axis and 15 on y-axis. The rotation is 6. Duration is 1 with a delay of 0.6, and the hex color is FFAB05. Emission is 1 as a burst. Velocity over lifetime is minus 40 on the y-axis. And we are using sub-emitters for all of the children. Only the tube and the light has inherit color. Everything else has nothing. For the renderer, we are using a mesh as rock and a material for rock. Order in layer 3. Let's go with the first addition, which is smoke. We are using a looping smoke with a duration of 1, start speed of 1.5, start color of 74 as alpha. Emission is 50. The shape is a sphere. Velocity over lifetime is minus 0.2 to 0.2 positive. Limit velocity over lifetime is 1.2 and with a dampen of 0.1. Inherit velocity is 0.05. Color over lifetime is hex color of EC791A, and the second color being 824D44, which goes to black alpha. Size over lifetime, we are starting with 0.22 as value 0 and ending at 1 with value of 1. The renderer is using a billboard with a matte smoke and order in layer is 1. Then we have the particles. The particles are using 1 as looping. Start color being E0B964. Emission is 80. Shape is a cone. Velocity over lifetime is 6 on the y-axis. Limit velocity over lifetime is speed of 4, which ends at 0.29 value. Don't forget to dampen the speed to 0.6 and drag 1.1. Color over lifetime is a early alpha and white color. You can copy this and reuse it in most of the other particle systems. Size over lifetime starts with 0 and ends at 1 on time 1.17. Also ends at 0. Noise is using 0.92 strength with a frequency of 1 and scroll speed of 0.2. Texture sheet emission is 2x2. And the renderer is a stretch billboard with ember material and using ordinary layer as 5. Then we have the beam. Duration of 1, start color of 255. Emission is 1 and burst is 1. Inherit velocity is enabled as 1. And we have a renderer for the billboard using skill shader beam 02. Also check for the pivot as the X is minus 0.5. Ordinary layer is 2. Then we have the glow with the duration of 1, lifetime of 0.7 and start color of 255. Max particles can be 1. The emission is 1 as a burst. Shape is a box, but we don't really need it. Inherit velocity as 1. Renderer is a mesh with a mesh cone and the skill shader glow 02. Then we have the tube. The tube is a small glow. We have duration of 1 and the start color of 76. The emission is 1. Velocity is enabled. Color or lifetime is the same as before. Mostly early alpha and color white. The renderer is using a vertical billboard with a sphere material. And lastly, we are using a light source. The duration is 1, lifetime is 3, and the start color is C56900. Emission is 1 as a burst. Velocity enabled. Color or lifetime is the same. Lights are enabled. We have made a separate prefab for the lights. What I did for the light source was that I created a new light, point light, and drag and drop this to my asset folder to create the new prefab. So you can easily reuse it everywhere else. I'm using a point light with a real-time mode with a color of white, intensity 2, indirect multiplier 2, and a range of 10. And also using no shadows for now. With range 5 and intensity multiplier as 10. The renderer is enabled. Let's also play them together with phase 1 and 2. So we have the intro and we have the flying meteorite. Let's move on to phase 3. We are using a flash. The flash here has 2 on the y-axis as a position. The duration is 0.4 with a start color of F19701. It has a pretty short lifetime for 0.25. The emission is 1 on the burst. Color over lifetime is the same as before with the early alpha. Size over lifetime starts at 0. The next key is 0.9 value with the time of 0.05. The last key is time 1 with the value of 0.7. The renderer has a horizontal billboard with a matte flare. Order in layer is 6. Then we have the debris. The position is 1.5 and the duration is 2. Don't forget that everything, or mostly everything in phase 3 has a delay of 1. The start speed is 0.5 to 0.8. The gravity modifier is 4, but this greatly depends on your Unity gravity settings. The emission is burst from 3 to 5 since those are the big rocks. We have the shape of a hemisphere, velocity over lifetime, here are the main settings, and then we have the speed modifier. It starts off as 1 and ends with 0.35 with value 0. Color over lifetime is the same, but not needed for now. Rotation over lifetime is random between 2 curves. It starts with 680 and ends at 0.13 and on time with value of 0. The collision is whirled and we have the radius scale of 10.76 with dampen and bounce. The renderer is using a mesh with a mesh rock and a material of rock 02. Then we have the small debris. We have the duration set as 2, start color as alpha, full, 255. The emission goes from 15 to 45. The shape is a hemisphere. Velocity over lifetime is 5.10.5 with the speed modifier of 1, which ends at 0.35. Rotation over lifetime is exactly the same. It ends at 0.13 and starts with a base of 680 with random between 2 curves. The collision is mostly the same. The renderer is a mesh with a rock and a matte rock. Then we have the fire. The position is 0.5 and the duration is 3. Start color, you can use the same from before, or you can do F18 711. Stop action, we can hit callback and always simulate, as for everything else. Emission is 10 with a burst of 5. The shape is a hemisphere again, and the force lifetime is 2 on the y-axis using a world space. Color over lifetime is mostly the same with some tweaks. Size over lifetime goes from 0 to 1. Texture sheet animation is 2. And the renderer is using a billboard. Then we have the fire explosion, which are coming from the sides. We have the position of 0.5 with a duration of 3 and the start color of F19 711 again. Stop action, we can also set as callback and always simulate. Emission is 15 as a burst. Shape is 3 with a hemisphere. Scale is -0.7 or z-axis. Force over lifetime is 2 on the y-axis on world space. Color over lifetime could be the same as the fire. Size over lifetime goes from 0.6 to 1. Texture sheet animation is 2 by 2. The renderer is using a billboard with a matte fire. Then we are going with a distortion. The distortion has a lifetime of 5 and a duration of 1, with a start color of alpha 255. Emission is 1 and shape is a box, but we don't really even need it. Force over lifetime could also be 0 right now. The color over lifetime is mostly at towards the end with a full blend. The renderer has a mesh funnel and a distortion shader. For particles, we are going with a duration of 3 and the hex color of E0B964 with the same delay as 1. Emission is 50 on rate over time and burst 30. The shape is a hemisphere. Velocity over lifetime is 1 on the y-axis. Limit velocity over lifetime is speed of 4, which ends at 0.52 and starts at 1. For the drag, it's set as 5 and ends at 0. Color over lifetime is the same as before. Size over lifetime. Size over lifetime starts with 0 with an additional key set to 1.17, which ends back down at 0. Rotation over lifetime is 155. Rotation by speed is 45. Noise strength is 2, which starts at 0 and ends at 1. Texture sheet animation is 2 by 2, and we're using a stretch billboard with a matte ember 1 material. Ordinary layer is 5. Then we have the beam. The beam's position on the x-axis is -0.75. It has a duration of 1 and lifetime of 0.3 with a start color of 255 as alpha. The emission is 1 and burst is 1. Inherit velocity is enabled. Color over lifetime is the same. Size over lifetime is 1 on the x-axis, but has the first key on 0.54, the second key on 0.91, and ends on 0. On the y-axis, it starts as 0.54 and ends on 0.59 with a time and value of 1. On the z-axis, it starts with the value of 0.54 and ends with the value of 1. but the time being 0.49. The renderer is using a billboard with the skill shader beam 01 and the order in layer is 2. Then we have the smoke. Position is 1 on the y-axis. The duration is 3 and the delay is 1. We're using the start color of A4825D and the end color of 905932. Emission is 6. The shape is a cone. Velocity over lifetime is enabled. Color over lifetime is the same as before with some minor tweaks. Size over lifetime on the x-axis starts with the value of 0.59 and ends with the value of 1. On the y-axis, it starts with the value of 0.59 and ends as 1 as well. And the same goes for z. It's using a billboard with the matte smoke material. Pivot is 0.23. Then we have the glow. Duration of 1 and start color of 255. The emission is 1. The shape, we can disable this. Color over lifetime is mostly the same with the early alpha and color. Size over lifetime is 1 on the x-axis, the same goes for z. And then we have the y-axis, which starts with 2 and ends with 0.5 value. Rotation over lifetime is 15 on the y-axis. The renderer is using a mesh funnel 02 and a skill shader glow 01. Order in layer is 2. Then we have the ground dirt. The position is 0.2 since we're not using a decal right now. We have the duration of 1 and the delay of 0.95. Start color is black. Emission is 1. Color over lifetime is mostly full alpha at the beginning. Size over lifetime starts with the value of 0.34. The second key is at 1 with a time of 0.01 and ends at 1. The renderer is using a mesh quad and a matte ground 01. Lastly, we have the ground glow. We have the Y position of 0.3. We have duration of 1. The same goes for start delay as the last one, with a lifetime of 5. Start color is 255. Emission is 1 as a burst. Color over lifetime is the same as before. Size over lifetime is 0.34 as the first key. The second key is 1, but the time is 0.01, and the last key ends at 1. With the renderer being a mesh renderer with the mesh quad and the skill shader ground 01. And there you have it. The phase 3 is ready as well. So we can play this one and we can play all of the phases now together. Let's take a look how I made the skill shader itself. The skill shader looks like this. Here we can see the settings. So we have the active target of universal render pipeline. For the material, it's unlit, no overrides, surface type transparent, blending mode alpha, render phase both, depth right is auto, depth test is equal, no clipping, no shadows. Currently no LOD crossfade, but depends on the project, and everything else is turned off. Let's begin with the textures themselves. Here I added 3 sample texture 2D nodes. First one I added a main texture, texture 2D, and for the second and third one I added a secondary texture, texture 2D. Then I blended the second part together using a texture blend 1 float, and I blended the first part and the 2 second parts together with another blend called texture blend 2. Here for both of them we have overlay mode. After, we multiplied them with a multiply texture 1. This is our first base. After this, we can also add a multiply, which we're gonna need later, because this is connected to distortion, and a second multiply, which is controlled by the alpha. Let's take a look at the alpha part. We have a alpha rotation float with a rotate, using a radiance, with a tiling and offset, using a alpha tiling vector 2. The offset is connected to a multiply and alpha speed. The tiling and offset itself goes to UV with a sample texture 2D, alpha texture 2D node. Here we have the speed. The speed is being connected to a time node. This is a really simple time box that I am using in all of my shaders. So we have a float called time speed, and we have a time 1 connected to a multiply B. Here we take the outs and we are connecting it to the alpha. Next up, we can look at the main tiling. So here we have the main tiling rotation float, a rotate with a radiance, tiling and offset with a main tiling of vector 2. We have the main tiling speed, which is a float with a multiply connected to the offset. From here, we have a multiply and we have a boolean. This is for main tiling on and off switch, because for some of the effects we don't perhaps want it. And we are using a add node, which connects to distortion. This you can connect to the texture UV itself. Then we have the secondary tiling, and this is connected to sample texture 2 and sample texture 3, because those should share the same tiling. Here we have a secondary tiling rotation float, a rotate with a radiance, tiling and offset with a secondary tiling vector 2, secondary tiling speed, and a multiply. And the speed is also connected to a time node. Both of them are connected to the sample textures. Then we have the distortion, also connected from the speed itself. This is controlling the distortion mask tiling speed and the distortion speed itself. So you're adding two multiplies here. The first distortion speed is controlled from a vector 2, which goes to tiling and offset, and we're also using a vector 2 node here. This connects to the sample texture 2D node. And here I am using also two of them. So the first one has a distortion texture connected, the second one as well, but the second one is made for a mask. For the mask itself, we are using the same texture, but we are using a distortion mask tiling. So this is a vector 2 and a distortion mask speed. The tiling itself is connected to a distortion texture, which is connected to a multiply. And we're multiplying it with a UV0. Then we're doing a lerp with a distortion amount currently set as float. And we are adding it with a UV1, which is a split from alpha. This we are connecting to the main tiling itself. So we are adding it with the main texture tiling. The second part of the distortion mask tiling, using the same texture node, goes to this first multiply that we added after the texture group itself. Then for the second multiply, we are connecting it to the alpha that we made. From here, we can take a look at the color ramp. We're using a output from the multiply, which goes to a subtract of 1. Here we're using a vector 2 connected to a sample texture 2D UV, and we're using a texture 2D node for this. Here, for the texture size itself, we are using a texture size node, and here we need to use the texel height. We are multiplying it with a float called the texture ramp index and dividing it by 2, which is then both connected to an add. And the add itself goes to a vector 2 and goes to sample texture. Then for the color part, we're multiplying it with a color. Here we are using an HDR color. And for the alpha, we are multiplying a vertex color split alpha to the whole color ramp itself. For the color part, we also want to add Fresnel. This isn't needed for all of the effects, but it is good to have because you can add some nice additional variety to some of the effects. So for the alpha itself, we can just make an output and connect it straight to the fragment itself. The alpha part we don't need to touch anymore, but for the main color, we are using a connection to a branch. So you can connect it straight to branch false, and we have a branch true and predicate is front face. So let's take a look at the Fresnel itself. We are using a vertex color for this one, so you can use it later in the particle systems. So the vertex color output goes to a branch, which is true and false is 1. For the branch itself, we're gonna make a boolean color Fresnel on and off, so you can swap it if you want. This is connected to a multiply, and we're using the same color node that we used before. And this goes to the lerp t node. For the Fresnel, we're gonna add a Fresnel node, and for the power, we're using a float, both in world space. From here, we're gonna take a 1- and go use it for the branch. Here we have another boolean called invert Fresnel off and on. Then we add it through a saturate node and multiply it by the Fresnel scale, which is also a float 1, and connect it to the lerp b node. Here for the output, we are using a Fresnel on and off, so this goes for on. And we do 3 connections from the multiply color itself. So the first one goes to lerp, the second one goes to Fresnel off, and the third one goes to false. And in the end, you can connect all of them together. For this shader, we are not using any texture 2Ds, but we are just using shader math. We can start off by looking at the graph inspector. So the main settings are material for unlit, surface type is transparent, blending mode is alpha, render phase both, and everything else is unchecked. And active target, we are using universal. We can start off by having rotate node with a distortion with rotation as a float, which is connected to a tiling and offset. Tiling itself is controlled by distortion scale. So the current values are 5 and 5, but you can set them to 0 as the base values. The tiling and offset is controlled by distortion speed, which is a float, and connected with the time and multiplied. Here, both of them are connected to a simple noise, which is also multiplied by distortion multiply. I'm using a simple noise instead of a texture 2D just to save a bit on rendering cost. The simple noise multiply is connected to an add node, which is also connected by a screen position default. The output from the add node leads to a scene color, which then leads to a base color fragment. From the simple noise itself, we do another connection, which leads to a multiply, which is connected to a vertex color. This leads to the alpha fragment. And that's it. That's the whole shader itself. So here we have the texture ramp. The canvas size is 256 by 30. Each pixel is a separate ramp. We're using a rectangle tool to fill it up with a gradient, so those are the hex colors. The fire effect is the first texture ramp index, and the second one is a frost. Everything else I've just kept as an extra, and you can build it how you want. And then I just exported it as a PNG. For the circle texture, we are starting off with the Photoshop ellipse tool. Then we are creating a mask from it and are painting in some of those edges. I'm also leaving room for some dark areas on the inner sides and making a gradient glow around it. Then I'm painting in some contrasty thinner edges. The embers are pretty small usually, but we still want to give them some kind of sharpness to the edges, so they look visually a bit more interesting at least. Usually Diablo series does a 2x2, so that's what we're doing here. If you're going with the hand-painted embers, then think about the logic of how it would fizzle out at the end. So then you can think a bit more on how the shape would evolve during its lifetime. For the smoke, I'm starting with the star shape, because the smoke needs to go up. This is what we've seen from the Diablo footage as well, that the smoke itself should have some kind of a shape to it. I think the best tool for creating smoke textures is the brushes themselves. And here, I'm using David Harrington brush set. You can check it out online as well. Once I have the final shape locked in, I'm going to be adding more contrast to the middle smoke shape itself. This will help the players with readability of the shape. For the second smoke, I used a middle point from the first smoke and started testing and playing around with the smudge tool. This helped me get this kind of a swirly shape. I also played around duplicating the same texture again and just rotating them around slightly, just to see if I can get a better sense for the shape. I added some blur effect, just to help sell the idea of it being a burning smoky effect. For the fire texture, this shares the logic of painting smoke. It has those brighter values at the edge and darker values in the middle, or a bit more blurry areas. When I got the first texture how I wanted it to look like, I duplicated them 3 times because this is a 2x2, and together with the smudge tool, I added some additional movement to those textures. When you have all of those textures side by side, it's a great way to see how its lifetime should look like. Once you're happy with the result, you can add some additional glow. For the ground texture, I tried to get the initial shape in first. So we have this kind of spider web slash cracks in the ground effect, which we could fill with fiery shader later. I noticed that the thinner edges work a bit better with having more glow and gradient just around them instead of having a bunch of thicker shapes. For the second ground texture, I knew that this was going to be the ground explosion, so this had to have those kind of a spiky edges and more of a white gradient in the middle part. For the rock texture, I found a volcanic image, so this seemed to be fitting the most for the meteorite. What I did was, I used a mixture of black and white levels and a curve filter, just to even out the black and white values. Here we have the textures in Substance. I did half of the textures in Substance Designer, just to show that you can do it both in Substance, or you can do it in Photoshop, or you can do all of those textures in any other program, because it really doesn't matter where you create them. But for the first noise, the goal is to create a fiery noise that has the feeling of it being a hand-drawn noise, since we want to stay in the same style with the Photoshop textures. Because when you're creating textures in Substance Designer, they can look a bit too uniform and not stylized enough. So that's what I'm trying to achieve here. For the edit, it's usually make it tileable and auto levels. Then for the output, we go with the levels node and we are checking for the gradient colors. This is important to see how they would look like with a gradient ramp, otherwise we don't really know before exporting. For the second noise, the goal is to have a noise with randomized holes in them, to have a great base for the fire texture. And to achieve this, we're starting with clouds and a cell noise. The order of logic is usually the same. I'm starting off with a couple of different noises, then they go through a couple of blurs and a couple of warps, and then we have the edit part. For the edit part, since it's a noise, I usually make it tileable, which is the most important part since the noise needs to always be tiling without any sharp edges or cuts. For the noise 3, the main goal is to have a fire looking distortion noise to support both the fiery textures and the heat distortion look to the texture blends. This will be the most complicated one with different clouds, cell and Berlin noise. We want to break down the basic noise feeling and make it look like it's a fiery texture moving on its side. Once I have used the transformation node, I added a make it tile node after it, because this can cause issues if you don't solve this immediately. Getting a tileable noise texture while having multiple transformation nodes inside it can complicate things. So it's better to just make it tileable as soon as you're using a transformation node. Here we have the same edit part with a make it tileable and some auto correction. Then we're going for the output. For the last noise texture, this one is the most basic one and gives us a lot of freedom to add that extra touch of randomness to the side-scrolling fire. We're using clouds 1 and Berlin noise, which we have tweaked with the directional warp and the blur. Then we're combining them with the cells 1 and having an edit node. Then is the same output. I have just duplicated the output node pack, so it's always the same. Then we have a sphere texture. It's a pretty simple one, just a shape with a transformation node and auto levels, and goes out with the same output. Then we have the flare texture. It was a bit more difficult to get right, because we need the basic shape to be able to be warped in different directions and have this kind of out glowing effect. So I blended two different kinds of shapes together. One of them went with the warp and the other with the histogram scan. Since we're in Substance, it's really easy to go back and tweak the settings and get a bit of a different result for this kind of flare. So you can have how many ever flare edges that you want. And here, just going for the same kind of output. And here we have the trail. For the trail, I went with 3 different shapes and rotated them on different angles. This helped us get a bit more of a cone shaped, and I used a mask with a spherical shape just to even it out. This helps us out with a fiery beam effect, which we will be using as a mask. But last but not least is the second trail texture. This texture we will be using a lot as a mask as well. If we need this kind of a flamey, mask won't look so uniform always on the materials. Once we're done with all of the warping and blends, we have the mask. And for the mask, we're using a gradient shape together with a blur to get rid of those sharp edges. And we have the same edit and outputs for checking the gradients. And that's it. Those are all of our substance textures. So let's jump on to the next part. For the rock mesh, I started with a platonic mesh, which is a icosahedron with a subdivision of 4 and radius of 5. Then I started sculpting. After which I did the mesh retopologize. Once you're happy with the results, go to mesh reduce, about 75%, and for the UVs, you go to UV automatic with 6 planes. For the funnel one, I started with a cylinder from which I removed the top and bottom part and reduced it in height. Then I did a cut in the middle with a multi-cut tool and stressed out the middle part. Then you add 2 more cuts to the middle and smooth them out. For the UVs, you select the mesh and go with modify unitize. Then select all of the edges and leave out 1 edge for the cut. Then select and move and sew. Then select arrange layout and cut it in half. and move the bottom part to the upper corner and upper part outside of the first UV box. For the funnel 2, you start with the tube. Remove the inner part and start stretching the tube out in the shape of a cup, with some slight tilt towards the middle part for the flames. For the UVs, go to Modify, Unitize, then add a cut in the middle, then select Move and Sew, after which go to Layout and Rotate. And it should be ready. For a cone shape, start with the cylinder, rotate it on the side and stretch it out, add a middle cut and edge cuts for the shape, and make the overall shape look like a bullet, which is connected on both ends. Add a UV material for better visibility and select the whole mesh. Click Modify Unitize, then select all edges except for a long cut in the middle and all inner edges of both tips. Then select Move and Sew, after which click Layout and Rotate. For the last part, I'm just making a regular plane with the subdivision height and width is 1. We're just using this in some cases instead of the Unity spillboard. Next up, let's take a look at the materials themselves. Let's begin with the glow. The glow material is a VFX skill shader glow 3. Those are the texture settings. So, for the main texture, it's using a texture noise 3. For the secondary texture, it's using a noise 2. For the alpha texture, we are using a trail 2. For the distortion, we are also using noise 2. And for the color ramp, it's the same texture. The glow is also using a mesh funnel 1. Then we have the distortion. The distortion is using a mesh funnel 2. And it's using the distortion shader. We are using a 20 by 20 tiling. The multiply is 0.003. Rotation is 1 and speed is 1. For the particles, we are using a matte ember 01. This is using a Unity Zone particle standard unlit. The rendering mode is additive and color mode is multiply. Here we are using the intensity of 2.4 and the texture is the embers. Here for the alpha source, it's input texture alpha and alpha is transparency. For the ground, we are using a mesh quad. And for the material, we are using a circle 1. The circle 1 texture or material is using a universal render pipeline particles unlit, surface type transparent, blending mode alpha, render face front, and color mode multiply. It's also using a 255 for the alpha. And this is using our texture circle 1. Input texture alpha, check, and alpha is transparency. The phase 2 is using a rock mesh that we made, but I would recommend using a rock model from your own game. For the material, I created a universal render pipeline lit with a metallic, surface type opaque, and render face both. I'm using a rock texture. For the base map, for the color, this is the hex code. We're using a normal map that I just generated from the base map. And we are using a emission which has the intensity of 2 and is using the noise 3. Also, I have checked for enable GPU instancing. For the smoke that we can see here, we are using a billboard with the matte smoke 2. The matte smoke 2 is using a universal render pipeline with particles unlit shader, surface type transparent, blending mode alpha, render face front, and color mode multiply. And the base map is a text smoke 2 with input texture alpha, and alpha is transparency. For the particles, we are using the same as before. It's the embers. For the beam, we are using a skill shader beam 2. Skill shader beam 2 is using the shader that we made with the main texture of noise 3, the secondary texture of noise 2. The alpha texture is a trail 1. The same goes for the alpha source, input texture alpha, and alpha is transparency. Distortion uses the noise 2. And we're using the color ramp. At the moment, the texture ramp index is 0 because we are using the first texture. And for the glow, we are using a mesh cone 1 with a scale of 1. And we're using the skill shader glow 2. The main texture is missing. The secondary texture is a noise 2. The alpha texture is a trail 2 with alpha is transparency and input texture alpha. For the distortion, we're using the noise 1. And color ramp is the same, and the color is 2.4. Then we have the tube, which is a matte sphere. The matte sphere is using a universal render pipeline particles unlit. The surface type is transparent, blending mode additive, render face front, and color mode color. This is using a full alpha and using our text sphere. Also, the same is for this one with the input texture alpha, and alpha is transparency. And for the light, we are using the point light that we created using no shadows. For the flash, we are using a billboard with the matte flare. The matte flare is using universal render pipeline particles unlit with the surface type transparent, blending mode alpha, render face front, color mode color, and it's using a flare texture. Input texture alpha, and alpha is transparency. The debris is using our mesh rock and the matte rock 2. So this is just a duplicate version of the matte rock material 1, but it's just using less emission because we don't want all of the debris on the ground to be emitting light. Debris is small is using mesh rock 1 and matte rock 2. For the fire on the ground, we're using a billboard with a matte fire. This is a universal render pipeline particles unlit shader with the surface type of transparent, blending mode alpha, render face front, and color mode color. Here we are using the fire texture that we made. Input texture alpha, alpha is transparency. For the fire explosion that's on the sides, he's using the same thing. Here we also have the distortion. So we are using the mesh funnel 2. And we are using the same distortion shader. For the particles, this is something that we looked at as well. It's using the ember. Then we have the beam. The beam is using the beam 1 shader, which we made. The main texture has noise 3. The secondary texture is noise 2. The alpha texture is a trail. For the distortion, we are using a noise 2. And for the color ramp, we are using the ramp texture. For the ramp texture, we are using a input texture alpha. Alpha is transparency. Non-power of 2, none. Wrap mode clamp, and filter mode point, no filter. This is the resize. The format is automatic and no compression. For the smoke, we are using a smoke material. This is with the universal render pipeline, particles unlit, surface type transparent, blending mode alpha, render phase both, and color mode multiply. Here we are using the smoke texture that we made. For the tubular glow, we're using the funnel 2 mesh. And we are using the skill shader glow 1. For the main texture, we're using a noise 1. For the secondary texture, we are using the noise 2. For the alpha texture, we are using the trail. And for the distortion, we are using a noise 1. Also, the color ramp. For the ground dirt, we are using a mesh quad. And for the material, we are using a matte ground. The matte ground has the universal render pipeline particles unlit. For the surface type, it's transparent. Blending mode is alpha, render phase front, color mode multiply, and is using the text ground 2. Input texture alpha, alpha is transparency. For the ground glow, we are using a mesh quad. And a skill shader ground 1. The ground 1 is using noise 1 as the main texture, noise 2 as the secondary texture. The alpha texture is VFX ground 1, input texture alpha, and alpha is transparency. For the distortion, we're using a noise 1 and color ramp. Once the whole effect is done, we can check with the rendering debugger. You can set the max overdraw count. Right now I have set it to 10, and you can see where the white spots are as the most overdraw. To optimize this, you can either decrease the amount of particles or you can disable the unnecessary particle systems, but it's up to you. Each project is obviously different and has its own tools, but you still need to check out for having too much overdraw. For the frost variant, we're gonna swap out all of our hex codes from fiery red to our cold blues. Then we're gonna pick the materials and swap texture ramp index from 0 to 1 because we have a second gradient layer on the texture itself from Photoshop. And we're gonna swap out all of the emissions and base color material hex codes. And there you have it. It should be as simple as that. Hopefully this tutorial gave you some useful techniques for building stylized ARPG effects for your own game. Why I chose Maya, Photoshop and Substance Designer is that they are the industry standard tools for VFX. You can obviously use other tools as well, but when applying for a position, those you should be able to use to some extent. But of course there are other free variants available as well. And just to mention, the goal here wasn't to perfectly recreate the ability, even though the final result ended up getting pretty close visually. The main purpose was to show the workflow and techniques. Leave a suggestion in the comments what skill or boss ability or mob affix or any kind of effects you would like me to create next. Thanks for watching and I'll see you in the next one.